Hi everyone, and thank you for joining me. In this video, you are going to discover how you can apply machine learning to the admission datasets. This admission dataset, we've been on it for some weeks now, and right now we are on the machine learning aspect of it. Before we go into the machine learning, I will just quickly do an overview. Machine learning is very influential and one of the most powerful technologies in the world, and currently it is developing, and I believe, just like many of the other people do, that we are yet to fully harness its potentials. So machine learning there are different areas of machine learning. We have classical machine learning, SMO method, reinforcement learning, the neural nets. For the focus of today's tutorials, we'll be focusing on supervised machine learning. Supervised machine learning is a kind of machine learning where you already know the targets. For unsupervised machine learning, you don't know your targets. You're just trying to get something like a cluster. But when it comes to supervised, you already know your targets. Like in this admission datasets, we are trying to predict the chances of admission, and it is a supervised machine learning algorithm. So, and we can do it using regression and classification. For regression, you are trying to predict a value, you are predicting a number. And for classification, that is when you are predicting a class. As we can see, the most popular regression is linear regression, and we also have different kinds of regression. And for classification, we have different models: naive Bayes, SVM, decision tree, logistic regression. We have XGBoost, decision tree, and the likes. So each of the model depends on what you want to do and the problem in question. So for you to choose a particular model, you have to look for the best model. You have to experiment, because if a model is the best now, it doesn't mean that for every data it's going to be the best model. I will quickly show us the machine learning workflow. The figure above shows the machine learning workflow. Usually it starts with the data, and then you divide your data into a training dataset and a testing dataset. Sometimes you divide your data into three. You have the training set, you have the testing set, and you have the validation set. For this tutorial, we are going to focus on the training datasets and the testing datasets. And then when you have your testing dataset, the training dataset is what you use to develop the algorithm, and then you evaluate the algorithm based on the testing datasets. And then after evaluation, you have your model, and then you predict your model, or you can use your model for production. In case you have a validation dataset, then before using your model to predict or using your model for production, then you can further test that model with the validation dataset. So it is the standard practice for you to have a validation dataset, although in this tutorial I will just show you the training dataset and the testing datasets. So I'll just go to the notebook now, where we are going to see. So if we want to do a quick recap, I'll quickly show you the dataset. The dataset we have is the admission dataset in India, and this dataset shows the GRE, the TOEFL score, the university rating, SOP, LORAL, CGPA, research, probability. So we are using all those features to predict if it's the chances of a student having an admission. So for machine learning, we have input and we have output. the values that are inputs, we refer to them as the features, input feature, and then the output, we call it the targets. For the normal practice, we normally represent the features as X and then the target as Y. So for this case, GRE, TOEFL, university ranking, SOP, LOR, CGPA, and research, they are going to be our inputs. They will be the features, and probability or chances of admission is going to be our target. So we are going to do some Python programming here, and using this code df.iloc, we are going to select all the data in this column except for the last column. So we are just removing the last column. So if we run this, and then we can see that our features now, as the features for our data frame is now a data frame without the probability or the chances of admission column. And then for our target column, we are going to choose just the target column, removing other columns. So as you can see, that is the column for targets. So now that we have the column for features and the column for targets, the next thing we do is we'll split our data into training and testing data sets. For us to split our data, we split the data using a package called train test split. The train test split, for you to use the train test split, you have to first install scikit-learn on your computer. You can install scikit-learn by doing pip install sklearn. When you do this, it's going to install all the packages of sklearn, and with that you can use it. So I have installed train test split, and all I will just do now is to import it, and we can import it by writing this code from sklearn.model_selection import train test split. And then for you to split, you put xtrain, xtest, ytrain, ytest, and then you call the function train test split, and then x, we've defined x above and y, and then the test size, you choose the test size. For this particular tutorial, we are using 0.2. You can use 0.3, 0.1, you can use 20%, 10%, 30%, depending on how much test size you want. And then we have set random state to 42. This is because we want to be able to reproduce our results. So it doesn't matter, you can use any number, but if you want to reproduce your result, it has to be the same number, because it gives different split for different random states. Let's run this and see. So as we can see, the total number of data that we have is 500. So splitting into now that we have the test size as 20%, we can see that is 100, and then the training set is 400. We are going to, after splitting into train and test datasets, we are going to try to develop a simple model or regression model with random forest regressor. So for us to do that, we need to import our random forest regressor, and that we do by from sklearn.assemble import random forest regressor, and then we import accuracy underscore score and mean square error, so that we can use that to evaluate the model. So after importing our package, the next thing that we do is we call that package random. This is the model. We build the model random forest. We set the number of estimates to 100, You can set it to different figures and you can play around with it. And then we are using the criteria here for MSE. For linear regression, we can actually evaluate our model using three different metrics, three main metrics, with the R-square or adjusted R-square, or the mean square error, or the mean absolute error. We need to note that most of the time when you want to show people, when you want to explain your model to people, you use the R-square because it gives it's explained in terms of percentage. But if you want to compare model from one model to another, you use the root mean square error because it will compare performance. It will show you the model that gives the least error, and then you can use the adjusted R-square if you want to consider overfitting problem. For this particular tutorial, we are using the mean square error, the MSE. So, and after building the model, what you do next is you fit the model, and after fitting the model, you use the model to predict. Let's just do it in stage so that you can so that we can see what comes out. So we first import and then we build the model, and after building the model we fit the model, and after fitting the model we predict. We predict. So if we want to predict, we run this, and then this is our model predicting values. But if you look at this, we've built a model. What we've done now, we've imported the package random forest regressor. We've built a model, we fit the model, and we've used that model to predict. That is just like that, machine learning. It is easy. But if the problem we have now is we have only tested a particular model. What if the model gave a wrong result? Or what if the model did not perform well? What if there are other models that can perform better than this model? So what we normally do is we compare different models, and that is what we are going to do now. So, but before we compare the model, let's do something. Let's check the feature importance. For feature importance, it helps to know which of the features actually make more, or which of the models is more influential in the model. That is what feature importance do. Before we do the feature importance, we are going to have this predictor column. For our predictor column, we just remove the probability because this is the target. So we remove the target column, which we want to know which of the inputs, which of the features influence the model. So we remove so after removing probability, and then we go ahead now to plot our feature importance. We are plotting our feature importance. We are using the bar chart and matplotlib. As you can see now, research plays the least amount, research has the least amount of influence. CGPA is played more role in the determination of the model. CGPA followed by GRE, followed by TOEFL, followed by SOP, LOR, and the likes. So what we can see from here is, for example, if we want to go by this model, we have to, for a student, for example, the students will know that to get admission, he has to focus more on having a good GRE, a good CGPA, followed by GRE, because it means even when you have more, when you do research or the university rating, the CGPA still plays a major role in getting the admission. So the students will focus more on the CGPA. So for any student that wants to have a graduate admission, then we have to say you have to focus on getting a good degree result in your degree before all the GRE and the TOEFL and then university rating comes into play, which is reasonable anyway. Yeah. So, and then we move forward now to develop other modules, and so that we can compare. Right now we import the modules first. From sklearn we've import linear regression, we've imported logistic regression, decision tree regressor, random forest, gradient regressor, other boost, extra tree, k-nearest neighbor, SVR, and Gaussians. We are doing I need to make it clear that I'm importing both the regression and classification model, because after we've developed the regression model, we are also going to develop the classification model. So if you wait to the end of this video, you see how we are going to do that. So right now we have imported the necessary models. So we are now going to create a form of dictionary. So we call this function, we call it regressor. So this is linear regression, decision tree, random forest regression. We are comparing 1, 2, 3, 4, 5, 6, 7, 8 different regressor, 8 different regression models to see which one is the best. So we are now going to loop through each of the model. We are going to fit the model through each of the model, and then we could see which of them perform best. So we are going to write this code for name model in regressors. That is this dictionary that we've created here. So for name model in regressor, model.fit, and then it predicts, and then we are going to use the RMS as we said earlier, and then we are going to print out the name and the RMS. So if you look at this, you can see in the RMS we need the figure that is close to 0, because we are going to look at the best model is the model that has the least RMS. That means that model has the least error. Considering this, we can see that linear regression with 0.06 is the best model in this case, and that is why the model that we've just created is that we created earlier is random forest. It has 0.065, so that means linear regression is better. That is why this is very important, because if we have created the model straight away, that means we might not be using the best model. It doesn't mean that the model we are using might not be good enough. It might be good enough, but it just shows that we can get something better. We can visualize this using the Seaborn bar plots, and as you can see, this picture speaks 1,000 words. We can see that linear regression has the least error, so it's the best model in this particular case. So we are going to go now to see how we can convert this problem to a classification problem and make our prediction. We've imported trained test splits earlier. We don't have to do that again, but what we are going to do now is we are going to change. If you look at our target variables, they are in values 0.92, 0.76, 0.72 and the likes. For us to do a classification, it has to be in terms of category. So that means it has to be 0, 1, as in we need to categorize it. So for us to change the category, what we are going to do is we are going to select a particular value for admission. So we are going to, if we believe that for you to be admitted, for a student to be admitted, if that student is in the 75% percentile, or maybe let's use 70 for 0.75. Let's assume students have 0.75 percentile. So that means so we are going to create a particular column. That column will be y_train column and y_test column. So it means it will give 1 for each value greater than 0.75. Else it will retain the value, else it will be 0 for each value in y_train and for each value in y_test. So doing that, we are going to create another column that is y_train and y_test that we are going to use for the classification model. Just as we do for regressor, we are going to create this dictionary. So this dictionary has logistic regression, decision tree, random forest, gradient boosting, classification, header boosting, extra trees, k nearest neighbor, support vectors, and Gaussian naive bias. So in this dictionary, so we create the dictionary, and after creating the dictionary, we are going to write this code. So we are this is an empty list, and then we are going to say for name model in classifier, when model equals to model, we fit the model, we use the model to predict, and then we append the accuracy score, and then we print the accuracy. So we are going to do that to determine which of the model is the best. So if we run this code, running this code, we can see logistic regression is giving us 0.87, decision tree is giving 0.87, random forest 0.89. The best model here, as we can see, is 0.9. If we want to change if we want to tweak our model, we can go back here and change, maybe if we say 0.8 for example. Let's run this and see. Okay, when we use 0.6, we are able to get a random forest model 0.96, decision tree 0.95, extra tree 0.96. So if that is one thing about it, so we need to tune these values, and then apart from tuning this value, we can as well, if we look at the model, we can still do some things to improve. We can perform hyperparameter tuning, like Greek search. There are different things we can do to improve this model. And another thing we can do to improve the model, we can perform standard scaling, because if we look at the values that we have, GRA 337, TOEFL 118, and other value is less than 10. So there is a possibility that in developing this model, these higher values have been favored in one way or the other. So it is better for us to do something that we call scaling or normalization in this case. So if we carry out normalization for this column, or we scale the whole data set, the whole features, it can help to improve the accuracy of this model. If you've been with me till this time, I want to thank you for watching this video. There will be more videos coming up in the future, and I want you to share this video, like my channel, and subscribe. And I'll see you next time. Bye.